Hello, Algebra 1. This is going to be going over the worksheet 9.4, which I assigned you. If you have any questions, please let me know if I didn't cover something quick enough for you. All right, so 9.3. So we already did 1, 2, and 3 in class, so that would be on yesterday's video at the end, so if you want to catch up on those. Let's come on down to problem number 9. So we have our x-intercepts at 4, 0 and 6, 0. What's halfway between those? Well, it looks like 5, so x equals 5 is the axis of symmetry. The vertex is going to share the x value of the axis of symmetry. Then I'm going to need to take 5 and plug it into each of these. So I'm going to get 2, and 5 minus 4, 5 minus 6. Do the math. 5 minus 4 is 1, 5 minus 6 is negative 1. 2 times 1 is 2, 2 times negative 1 is negative 2. So 5, negative 2 is down here. And if we want to find our y-intercept, plug 0 into this same equation. So I get 2, 0 minus 4, 0 minus 6. So 2 times negative 4 times negative 6, that's 24, that's 48. So think about where 0, 48 is. It's way, way, way up there. So don't even worry about trying to graph it. And then draw on your parabola. Problem number 2 looks a little bit different. We're pretty sure that we can get to this 2, 0, but this leads me to 0, 0. So I have 0, 0 right there, and I have 2, 0 there. The axis of symmetry, what's in between 0 and 2, and that would be x equals 1. So our axis of symmetry comes straight down. And our vertex lives there. So the 1 from the axis of symmetry goes in the x value. Then take 1, plug it into the above equation for each of your x values. So you're going to 5 times negative 1, which is equal to negative 5. So 1, negative 5 is down here. Notice right there, if I have an x value that's 0 on any of the points, that becomes the y-intercept automatically. So there's our parabola. Number 11, if we go ahead and get our intercepts, so setting each of those sets of parentheses equal to 0. So I get negative 3, 0, positive 3, 0. What's halfway in between negative 3 and positive 3? Yeah, that's right, 0. So, all right. There's our axis of symmetry. 0 is going to share the x portion. Plug 0 in here and here. So you have a negative out front. 0 plus 3, 0 minus 3. So negative times 3 times negative 3 is going to give you positive 9. So that's way up there. Notice we have that 0 there, so that's also the y-intercept. You can see it just on your graph that it's the dot's right there on the y-axis where the vertex is. There's our answer there. Number 12, our x-intercepts are going to be negative 5, 0 and negative 3, 0. Let me double check some real quick. Yes. Negative 5, 0 and negative 3, 0 is right there. So what number is halfway in between negative 5 and negative 3? Yeah, that'd be negative 4. So we're going to draw in our axis of symmetry. Our vertex is going to be at negative 4, comma, and we have to plug 4 into those x's. Don't forget the outside 3. So I'm going to get 3 times 1 times negative 1. 3 times 1 is 3. 3 times negative 1 is negative 3. So 4, negative 3, which is down here. And let's find our y-intercept. So I'm going to plug 0 into our original equation. So that's going to give me 3 times 5 times 3, which is 3 times 15. 15 times 3 is 45. So that's going to be way up there, so we're not going to try and graph it. And there's our parabola. Put an arrow on both sides. Take a look at number 13. Our intercepts are negative 1, 0 and negative 7, 0. So negative 1, 0 is there. Negative 7 zeros there. Well, it looks like it's in between. I think in between is going to be x equals negative 4. So we know the x component of the vertex. I'm going to take that negative 4, plug it back in the original. Don't forget the outside negative if there is one, which there is in this case. So that's going to give me negative 3 times 3. So negative times negative is positive. 3 times 3 is 9. So 4 positive 9 is way up here. Let's get our y-intercept. So I'm going to plug 0 into the original equation. Again, don't forget the negative out front. So that's going to give me negative 7, which is down here. Go ahead and graph our parabola. Looks like that. These we need to put them in factored form first. So I'm going to do a set of parentheses. I have x and x. All signs are positive. What two numbers multiply to give me 12? Add to give me 8, and that would be 2 and 6. 2 times 6 is 12. 2 plus 6 is 8. So my x-intercepts are going to be negative 2, 0 and negative 6, 0. So what's halfway in between negative 2 and negative 6? That would be x equals negative 4. Plug the negative 4 into the x component of the vertex, and I can either plug the negative 4 in here to those x's or these x's. So I'll just take it and plug them into these. So I'm going to get negative 4 plus 2, negative 4 plus 6. I get negative 2 times 2, which is negative 4. Falls right there. Let's see if we can't find our y-intercept. Let's plug 0 in. Remember what I spoke yesterday. I can plug 0 in there. Or if it's already in form, it's at positive 12. So it's 12 is up there. So the y-intercept will always be, if it's not factored, if it's in x squared, plus some x plus a number, it's always the number. So that's kind of cool. Let's put this in factored form. So I have x and x. I'll have one positive sign, one negative sign. What two numbers multiply to give me negative 8? Add to give me positive 2, and that would be positive 4, negative 2. 4 times negative 2 is negative 8. 4 minus 2 is 2, so that works. Our x-intercepts are negative 4, 0, and 2, 0. So it looks like it's halfway in between those. Let's say negative 1. What do you think? Isn't this about halfway in between those points? So my vertex is going to be negative 1 comma something. So I can take that negative 1, either plug it into those x's, or I can plug it into these x's. It's going to be the same answer. Plug it into our parentheses. So that's going to give me 3 times negative 3, which is going to give me negative 9. So 1 negative 9 is down here. And let's find our y-intercept. What was our shortcut? Should I plug it in there, or should I just take that? It's going to be the same answer, so I'm going to take the shorter way. There's our parabola. Okay, make sure you have the next packet. We're going to start dealing with these when they are in a form called vertex form. So this is for packet 9.4. And they write this as the general form when we're not using any numbers. We just have letters to represent where numbers would be. All right, so we're going to change them to this form. So these are already in that form. This is our general basic parabola. Notice I have 0, 0. But notice this. If it's in this form, says x minus 2, but it happens at x plus 2. So 2, 0 is where our vertex is. Okay, so 0, 0 on this one, and 2, 0 on this one. Take a look at this. I have x plus 3, but this happens at negative 3, so my vertex is at negative 3, 0. And this one, it's going to be at negative 1, 0. It's opposite. So if it's in parentheses, it will be the opposite direction, right or left shifting. Then we're going to change to these. So this is our basic one. So 0, 0. Notice I don't have parentheses here, but it went down. Because of this negative, it went down 2. So it's 0, negative 2. This one, because it's positive, went up. So 0, comma 1. This one went down, 0, negative 1. So when you don't have parentheses, it moves it up, down in the direction. If it's positive, it goes up. If it's negative, it goes down. And then these, notice the fractions. So the fraction makes it wider. So 1/2, 1/4 is like, tiny. But then when we change it to numbers, it makes it skinny. So the inside are skinny. The dotted is like the original. But then if I have a negative out front, it flips it upside down. So every vertex is at 0, 0. Why is that? It didn't have anything in parentheses. It didn't have like x plus a number, or it didn't do x, number squared, or it didn't do x squared plus or minus a number to move it up or down. So the a, if the a out front, so the ax squared, if this is negative, makes it upside down. If it's a number bigger than 1 or less than negative 1, it's going to make it skinny. And if the value a in front is a fraction or decimal, between negative 1 and 1, it would make it fat, okay, or wider. So if we have this is the general form. So I'm going to take the opposite of the negative h, so h, and then k. That's how we find our vertex. So an example would be if we had this. This would have a vertex at -5, -3. Okay, same idea. Make a table vertex in the middle, plug in, or we're going to use the 1-3-5 rule to plot. Okay, I think you're going to like this. It's kind of cool. So the first thing we want to do is we're going to figure out our vertex. So it's opposite one is inside, same outside. So under my vertex, I'm going to do this. Okay, so I'm going to plot 2, 3, which is here. Okay, the axis of symmetry, you automatically know that because you know the vertex, so the axis of symmetry is just going to be the same thing as the x value of the vertex. What is the y-intercept? We don't know at this point, but let's see if we can find it. So I'm going to plug 1 in, and I'm going to plug 0 in, and I'm going to plug 3 in, and I'm going to plug 4 in. Okay? Now, I don't have to plug those into the actual problem itself. I'm going to do something called pattern graph, and it's going to be whatever our a value is, the number out in front, which in this case is 1, times 1, 3, 5. So watch what I'm going to do. It's going to be the same type of thing every time. All right? So from the vertex, I'm going to go right 1, up 1. From the vertex, oops, it's supposed to stay up there. So I'm going to go right 1, up 1. I don't know what's going on here. What are you doing to me? Let's just use one color, see if we can make it work. So we have 2, 3, it's right there. X, I swear I'm not touching it. So right 2, up 3, stay right there. There's my vertex. Ay, ay, ay. I don't know what's going on here. Right 2, up 3. Why are you moving on me? So then I'm going to go, if I went right 1, up 1, this goes to 4. If I went right 1, up 1, this would go to 5. If I go left 1, up 1, that goes to 4. If I go left 1 and up another, or up 3, I already messed this up. So this is going to go right 1, up 1, and then it's going to go right 1, up 3. So add 3 to that, subtract 3 to that. We now have our y-intercept at 0, 1. Our x-intercepts, so let's see if we can start plotting this graph. So I have 2, 3 is there. For some reason, it does not like this graph. So I'm going to do my graph right here. So it's going to go, make it a little easier. All right, I'm just going to put this on my smartboard. So this is back on example 1. I kind of have to start over. I apologize, my computer screwed up. So this is example 1. We have y equals x minus 2 quantity squared plus 3. So we already determined the vertex is going to be opposite, same. So let's plot 2, 3. Axis of symmetry. Is going to be x equals 2. It's always the x component of the vertex. And then we're going to start filling out our table. So we have x, y. We label this. Add the middle one as the vertex. So we already found the vertex at 2, 3. And then we're going to fill in these values. So I'm going to go 3, 4, 1, 0. So that's to the right and to the left. All right. So on my parabola, I'm going to go for my vertex. I'm going to go right 1, up 1, left 1, up 1. And if I go right 1, up 1, or left 1, up 1, and then I'm going to go a little bit further. I'm going to go right 1, up 3, left 1, up 3. So if you look at those values, that's going to be at 4 comma, if I count up, 1, 2, 3, 4, 5, 6, 7. So notice I went up 1 here, and then I went up 3 here. Okay, and there's our parabola. We happen to know the y-intercept. The y-intercept is at 0, 7. Remember, anytime that value is at. X-intercepts do not exist on this problem because it's not going to cross the x-axis. All right, let's go and take a look at example number 2. So example 2, we have y equals negative x plus 5 quantity squared minus 1. So this negative out here is going to mean it opens upside down, okay? Let's go ahead and find our vertex. So I'm going to give you at negative 5. Remember, it's opposite of this, same as this. So negative 5, down 1. Okay. And let's start filling out our table. So the very middle is the vertex. So we're going to be at -5, -1. So if I go to the left, -6, go to the left, go to the right, go to the right. All right, because we have this negative, our pattern graph is going to be a times 135. So it'll be a negative. So -1, -3, -5. So watch what I do when I graph this. I'm going to go right 1, down 1, left 1, down 1. Okay, so this is now at -2, and that's at -2. And then if I go one more, I'm going to go right 1, down 3, left 1, down 3, which is going to happen in the middle of our graph. So if I go down 3, if I subtract 3 from that, I get to -5 and -5. If I want to find my y-intercept, my pattern graph, it's eventually going to cross over here someplace, but we can't see it right away. So what I'm going to do is remember the y-intercept is 0, comma something. So if I plug 0 into this, I'm going to get -0 plus 5 squared minus 1, which is 0. 0 plus 5 is 5. 5 squared is 25. There's the negative out front. So it's at 0, -26, which happens way far down. We don't have to worry about that. X-intercepts, do you notice, does it cross the x-axis? Yeah, does not cross. Okay, and that's okay. These are just some special cases that aren't crossing the x-axis. Let's take a look at example 3. So we have y equals 3 x minus 1 squared minus 10. My vertex is going to be opposite of this. So 1, same as this, -10. So 1, -10. Okay, so let's pattern graph this first. So notice we have a 3 out front. So it's usually a times 135. Well, that's a 3, so I'm going to go 3 times 135, which means this is going to change to 3, 9, 15. So it's going to open up. So I'm going to go right 1, up 3, left 1, up 3. And then I'm going to go ahead and go right 1, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Left 1 up there. This is my parabola. Okay. Yes, we have the axis of symmetry. That is the axis of symmetry we'll call AOS is x equals 1, because that's 1. So that technically is right in there. Okay. There's our parabola. We can easily get our values. We know the vertex is this, +1, -10. And then this one is going to be at 2. I added 3 to that, so -7. And this is at 0, -7. So we have the y-intercept is at 0, -7. And then I could find this value here. That's going to be 3 up 2. And this is going to be the left one. So this is going to be at -1, 2. And does it cross the x-axis? It crosses here and here. So x-axis, okay, it does cross, but if your pattern graph doesn't fall exactly on it, these are going to be, it does cross, and that's all I want you to know. If you wanted to truly find out what that exact value is, that's where, in this case, like the quadratic formula might work, or factoring or something like that. Okay. But as of right now, we can't see, we can see that they cross here and here, but I don't know the exact value of that. All right, so finish up worksheet 9.4. So it looks like 1 through 10. My video will be available for that. I will not be here on Friday. So on Friday this week, make sure you have your computer so you can find my video, and the sub will give you a packet again like I had today. The video will go over the 9.4 homework, and it will have a little bit of a lesson with it, and then work on the packet for Monday. Again, we're going to have a test on Wednesday next week, so make sure you're staying up to this. Ask me if you have any questions. Have a great day. Take care of one another.